Hello, friends. Welcome to Science Talk. I am your host, Jim Massa. I want to kind of bring to you a quick synopsis of four new studies that have been recently published. And these all deal with that global heating may increase to unexpected levels. Well, it depends who you talk to, right? But what they were looking at is basically what's going on with the ice. Okay. If climate heating continues as it is now and the planet continues warming as it is now, up to a third of Antarctic's ice shelf could end up in the ocean. Okay? At least one Antarctic glacier could basically, it's in imminent danger of total collapse and irreversible retreat if temperatures go on rising. This is the Thwaites Glacier, and behind that is the Pine Island. Evidence from the past in another research group confirms that at the end of the last ice age, Greenland's temperature rose by somewhere between 5°C and 16°C in just mere decades, in line with a cascade of climate change events. You have heard me say time and time again, if you want to have an idea what's going to happen in the future, look at the past. And once again, the IPCC is assuming linear increase, and that is wrong. It's exponentiating. I did a video, Lessons from the Early Eocene, where basically the researchers there said that a temperature increase of 7 to 9°C is likely by the end of the century. Certainly not the 3°C that you hear the IPCC bantering about. And some other models even say 9 to 11°C by 2100. And it's these various cascading effects, these positive feedback loops, this exponentiating that kicks in. Another study looking at climate change that occurred 14,600 years ago confirmed that as the ice retreated, sea levels rose at 10 times the current rate to 3.6 meters in just a century and 18 meters in a 500-year sequence. So that's 3.6 meters is about, for those who are not familiar with the metric system, that's about 10 to 12 feet, which would flood just about a lot of coastal areas. 18 meters, well, we're talking now like 60 feet or so. So each of these studies, looked at the complexity of the planetary climate machine, the role of the polar ice, etc. But the one common message that they had is that the climate change, the global warming is happening. It could accelerate and happen at unexpected speeds. That part of the Antarctic ice sheet that is actually floating on the sea, in other words, cantilevered past the land, the grounding line, were it all to melt, sea levels globally would remain much the same, but the ice sheet plays an important role in stabilizing the massive reserves of ice on the continental surface. So if you lose that ice sheet that is on the sea, okay, you're going to get some sea level increase, but then you lose that, the ice behind it just comes tumbling in, and that ice is what will lead to very large sea level increases. Ice shelves are important buffers preventing glaciers on land from flowing freely into the ocean and contributing to sea level rise. That is a statement from Ella Gilbert, a meteorologist at the University of Reading in the UK. When they collapse, then boom, you basically opening up the floodgates, figuratively and literally. She and colleagues report in the Journal of Geophysical Research Letters that their detailed study of the vulnerable platforms of floating ice around the continent revealed that 500,000 square kilometers of shelf, 34% in total, including 2/3 of all the ice off the Antarctic Peninsula, would become unstable if global temperatures rose by 4°C if things continue as they are. Now they say that, if we kept to the Paris Accord, we might be able to avoid significant sea level rise. Well, we'll see. We're already at 1.4, I don't see it slowing down. Two Antarctic glaciers are already responsible for around 10% of sea level rise at the current rate. That, of course, is Pine Island, Thwaites Glacier in West Antarctica. And they are in danger of imminent collapse. So you could even say that this study is a bit of an underestimation as well, that the sea level rise could even be more so just from those guys than all the other ice taken together. In another study published in The Cryosphere, other researchers identified several tipping points for the Pine Island glacier. The third of these tipping points, triggered by ocean temperatures that warmed just 1.2 C, would lead to irretrievable retreat of the entire glacier. And that's Hilmar Gudmundsson, a glaciologist at the UK's Northumbria University, one of the authors, called the research a major step forward in the understanding of the dynamics of the region. The findings of the study also concern me, he said. Should the glacier enter unstable, irreversible retreat, the impact on sea level could be measured in meters. And this study shows once the retreat starts, it might be impossible to halt it. And we know that, Pine Island, Thwaites would collapse, go into the ocean. Yeah, they're going to see massive, significant short-term sea level rises. Rapid polar melt is part of the pattern of climate history. Danish researchers reported in Nature Communications that on the evidence preserved in Greenland ice cores, they identified a series of 30 abrupt climate changes at the close of the last ice age, affecting North Atlantic Ocean current, wind, and rainfall patterns, the spread of sea ice. So a set of physical processes that changed altogether. Basically, you have this cascading effect ensuing. Now, those of you who've been following my channel for some time, you know all about North Atlantic Ocean currents, wind, rainfall pattern. So I'm not gonna, repeat that here. You can go to those videos and watch them, and I go into very great detail about these factors. Back to this third study. The precise order of events was difficult to ascertain, but during that sequence, the temperature of Greenland rose by 5 C to 16 C in decades to centuries. So the question remains open is, could such things happen today? The results emphasize the importance of trying to limit climate change by, for example, cutting anthropogenic emissions of CO2 and other greenhouse gases, both to reduce the predictable gradual climate change and to reduce the risk of future abrupt climate change, said Sune Olander Rasmussen of the Niels Bohr Institute in Copenhagen, one of the authors. I don't think what's happening can be described as gradual. When you look at the rate of change, another thing I have always stressed, and then you compare that to the age of the Earth, 4.5 billion years or so, it's pretty damn fast. So Dr. Rasmussen says, if you do not want the dominoes to topple over, you're better off not to push the table they stand on too much. Another study in the same journal, Nature Communications, by British scientists, reports on a close study of geological evidence to decipher the pattern of events during the largest and most rapid pulse of sea level rise at the close of the last ice age. Their study suggested that although the sea levels rose 18 meters in about 500 years, 3.6 meters a century, it all happened with relatively little help from a melting Antarctica. Basically, it's the great glaciers present on North America at the time, as those retreated, North America, Europe, and Asia, that's when the oceans rose. The next big question to work out is what triggered the ice melt and what impact the massive influx of meltwater had on ocean currents in the North Atlantic, said Pippa Whitehouse, University of Durham, one of the researchers. Any disruption to the Gulf Stream, for example, due to melting the Greenland ice sheet, will have significant for the UK climate. Will have significant consequences not only for the UK and Scandinavia region, but the entire planet. Now, it is true that a lot of the glacial, a lot of the sea level rising at the end of the last ice age was due to the great ice sheets melting back into the oceans. Okay, yes, because we know sea levels drop, but we know that Antarctica and Greenland are melting. We know this. And other studies have shown that if all those were to melt, sea levels could rise by up to 75 meters. It's like over 200 feet or so. And so I think they're kind of being a little bit dismissive, not really factoring in what's going on with Antarctica, because Antarctica is melting. We see constant fissures, constant chunks breaking off. Thwaites, Pine Island are in imminent danger of total collapse. Then there's the Brunt ice shelf, the Ross ice shelf. All this is happening, folks, and it is happening at a quick, increased rate and pace. So I'm going to take a little. I'm going to do a little pushback on that last study there, because I don't think they're quite taking into account what's going on with Antarctica, which the British Antarctic Survey team's been studying for decades, and they're documenting all this stuff. So sea level rises is going to probably be a little more significant than some of these studies are suggesting. But what's the take home from all these four taken together? Basically, things can happen so fast, things can change so fast that we can have unexpected results that are outside projections, outside what even the best modeling can project. So, and when you tie this into the things that you've heard me discuss numerous times, what's going on with AMOC and Greenland and the conveyor belt and deep water formation, et cetera, and let's not forget the ocean heat content. You're going to have heat diffusing from underneath that could melt any ice. So if you melt that quicker, you increase the sea levels quicker. So the point of this is that you can have unexpected, rapid increases in sea level rise, temperature, what have you, that are much faster than those who want to assume linear, or even those who are assuming exponentiating, that their best models could happen. In other words, things can change very rapidly within a matter of decades. And I think we're starting to see signs of that. It all depends what happens, ask me 10, 20 years from now. I'm still alive. As we get more data, our understanding improves. But this should still be a wake-up call for everyone. Thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.